we're going to put everything that we've talked about from this section together in one final example where we're going to work through a hypothesis testing question from start to finish. So suppose that in 2018, approximately 39% of all U.S. adults oppose the use of the death penalty. A politician claims that this proportion has increased since 2018. In a poll of 526 randomly selected U.S. adults showed that 220 opposed the use of the death penalty. We would like to know, is there evidence that the proportion has increased since 2018? We will use the significance level of alpha equals 0.01. So, as with all other hypothesis testing questions, the very first thing that I'm going to want to do is state what's the null hypothesis, what's the alternative hypothesis. So what is the claim that's being made? So what's H naught and what is HA? The null hypothesis, the alternative hypothesis right here is what I'm going to start with first. Actually, before I can do that, I need to decide what my parameter is. Here we're talking about a percentage or a proportion. In this case, if I look at that last sentence, is there evidence that the proportion, which means that our parameter will be P, so our parameter is a population proportion. And for the alternative hypothesis, the question that I'm asking, I want to know, is there evidence that the proportion has increased? Has it gone up? So in other words, is P greater than what it was in 2018? Well, in 2018, it was approximately 39%. So is it greater than 39%? So is P greater than 0.39? Once I have my alternative hypothesis, I can switch it around to find my null hypothesis pretty easily because it's always a statement of equality, and it's always going to be using that same number. So we're going to say P is equal to 0.39. So we have our null hypothesis, we have our alternative hypothesis. The other thing that I might do really quickly, just so that we have everything in front of us, let's go ahead and gather some information here. So I have my P naught, and if you want to make a separate note here, we know that P naught comes from our null and alternative hypothesis. That's 0.39. I'd like to know, what is P hat? What's my sample proportion? In this case, they didn't tell me what that is. They said in a poll out of 526, so out of 526 individuals, 220 said they opposed it. So 220 out of 526. I've got to do a little bit of division in order to find this. I ended up with 0.4183. I'm going to round to 4 decimal places, just to be certain. The other thing I'm going to need to know is, what is my sample size? N. N in this case we said was out of 526 randomly selected individuals. Our alpha is 0.01. That was given to us. The other thing that we're going to need, and I'm just going to make a quick note of it right now, is in our alternative hypothesis, we said P is greater than 0.39. That means we're doing a right-tailed test. A right-tailed test. That'll be important when we go to find our p-value. So this has everything we need. We've kind of laid out all of the information that problem has given us, and that's going to make the rest of our work a lot easier. So step 2 says we want to verify that the necessary conditions for hypothesis testing are met. These are going to be the same conditions as the central limit theorem. So we want to verify, do we have independent sampling? Which again, this is very difficult for us to show. We're going to just look for, do we have random sampling? In this case, we have, in a poll of 526 randomly selected U.S. adults. So yeah, we can go ahead and assume that we have independent sampling. The other condition that we want to check is the success-failure condition. So success-failure, failure. So that looks like n times p naught and n times 1 minus p naught. I just want to make sure that these are both greater than or equal to 10. So n is 526 times 0.4183. I should end up with roughly 220, but let's just make sure. 4183, I ended up with about 220.0258. We'll just leave it at 220. We'll round it to the nearest whole number here. That is greater than or equal to 10, so that works. And then 526 times 1 minus 0.4183. Again, 526 times 1 minus 0.4183. This time around, I ended up with roughly 306, which is still greater than or equal to 10. So both of these are verified. We've met our conditions, which basically means we can continue on with the problem. In some questions, I may just tell you, hey, you may assume that the conditions are met, in which case you don't have to show this step. You could skip this step. In general, if you're going to run into a problem, it's going to be with that success failure condition, because that's going to be the one that I ask you to verify the vast majority of the time. Moving on, step 3, here's where we're going to do all of our calculation. We want to find the standard error, the test statistic, and the p-value. And let me just copy this information right here, because we're going to need to reference all of these numbers. I'm just going to bring this down so that we have it in front of us. We want to start by finding the standard error, and then once we have that, we'll find the test statistic. Once we have that, we can find our p-value. So we're going to start with standard error, which all of these formulas are given right above this video if you need to take notes or reference them throughout your homework. But the standard error says square root of p naught times 1 minus p naught divided by n. Remember, p naught is coming from your null hypothesis. So standard error is square root of 0.39 times 1 minus 0.39 divided by n, my sample size, which is 526. So I'm going to grab my calculator real quick. Square root of 0.39 times 1 minus 0.39 divided by 526. I ended up with 0.0213 if I round to 4 decimal places. So here is my standard error to start. I have to do that before I can do anything else. So standard error, done. We've got that part. Next part it asks me to find is, the test statistic. So I want to find my test statistic. I like to write this out as my test statistic. My test stat is a z-score, and then I'm going to go ahead and write this out. I like to do this because, as we'll see in Chapter 7, our test statistic is not always going to be a z-score. We may use other probability distributions. We'll talk about eventually t distribution and chi-square distribution, which are both a little bit different. I like using the z because that helps me to remember, oh, I'm going to use my z-table when it comes time to find my p-value. So my test statistic formula says I want p hat, so p hat minus p naught divided by my standard error. So p hat, we said that was 0.4183, minus, what do we say, p naught, 0.39, divided by my standard error, which is 0.0213. So let me do this real quick, 0.4183 minus 0.39, and then we divide, and I ended up with roughly 1.33. I'm only going to round to 2 decimal places here because remember that this is a z-score. For my z-tables, it only tells me 2 decimal places, so that's all I can really use in this case. So my z-score is 1.33. The last thing that this problem asks me to find is the p-value. So for the p-value, I want to scroll all the way back up and determine what type of test we were doing. Here we said we were doing a right-tailed test, which means if I was to sketch this out on my normal distribution, I'm looking for the area in the right tail. So here we've got our test statistic. It's positive, so it's on the right, 1.33. And because it's a right-tailed test, we're looking at this area right here. So this is going to be area to the right because it's a right-tailed test, because our alternative hypothesis said greater than some number. So I'm basically looking for, hey, what is this area right here? We've got our test statistic, which is a z-score of 1.33. I just need to hop over to my z-table. So if I do that real quick, let's take a look. We said our z-score is 1.33. That's a positive z-score, so z is equal to 1.33. Where does that live? Well, here z is 1.3. We must be looking at this row. Here's the second decimal place is 3, so we're looking at, 0.9082. 0.9082. Remember, though, that this represents area to the left. I wanted area to the right. So we're just going to have to take the complement of that. But that should be relatively easy to do. So scrolling back to my problem, the area to the right would look like 1 minus 0.9082 because this is a right-tailed test. So subtracting that gives me 0.0918. This is my p-value. And this is how I'm going to make my decision at the end of this problem. So I have my p-value, I have my test statistic, I have my standard error. And in general, that's the order that you're going to find those in. You're going to start with your standard error, and you'll use that to find your test statistic, and then you'll use the test statistic to find the p-value. All right, let's move on to the last couple parts here. Number 4 says we want to state your decision, either reject H0 or do not reject H0. So we know two things. We know that our p-value is equal to 0.0918 from the last part, and we also need to know what is alpha. That was given to us in the problem. So in this case, if I scroll back up, we said we wanted to use alpha equal to 0.01. This is where I'm looking right here. So alpha is 0.01. Alpha is 0.01. Our decision-making rule at the end of this, if the p-value is less than alpha, we reject. If the p-value is not less than alpha, if the p-value is greater, we do not reject. In this case, the p-value is greater than alpha. So the p-value is greater than alpha, which means that we will not reject H0. So we do not reject H0. That's the decision that we're going to make here. So we do not reject H0, which then means in step 5, the very last step of this problem, when we go to interpret this, if we don't reject H0, then that means that there was not enough evidence to make us change our mind. So if I'm going to start this interpretation, I'm going to say something like, there is not enough evidence to support that. And now I want to talk about what this means in terms of the original problem. What's the claim that's being made? So if I scroll back up, usually it's that last sentence here. I'm going to erase all this just so that we can kind of start fresh and not get distracted. The question that was asked is there evidence that the proportion has increased since 2018? So I like to be a little bit more specific than that. The proportion of U.S. adults that oppose the death penalty. So I'm going to say in this interpretation that there's not enough evidence to support that the proportion of U.S. adults that oppose the death penalty has increased since 2018. And there's a lot of different ways you could write this last sentence. So I said has increased since 2018. You could say that the proportion of U.S. adults that oppose the death penalty is greater than 39% or something like that. There's a lot of different ways that you could phrase that. If you have questions about your specific interpretation, you can always shoot me an email and ask me about that. But that's roughly what it looks like. Take your time with these problems because there are a lot of steps. As we saw, there's 5 steps. There's a decent amount of calculation with these. If you get stuck on any particular step, please, please, please do not hesitate to reach out and ask me. The nice thing about hypothesis testing is we will get a lot of practice with these because as we're going to see, we're going to look at hypothesis testing in chapters 5, chapter 6, and chapter 7. And all of our hypothesis testing questions are going to look very similar to what we saw here. They're going to follow the same steps. Some of the formulas might change, but we're going to see the same. Step 1 is always going to be, what are your hypotheses? Step 2 is to check your conditions. Step 3 is to do your calculations. And step 4 is to make your decision. So we will get lots of practice before the end of this course with hypothesis testing.